Welcome to qnawire.
Hi, so in this case we're going to have a monoprotic weak acid. So this weak acid, when it comes into contact with water, it is going to be in an equilibrium where it can generate its conjugate base and donate one hydrogen to the water in order to generate H2O plus. So in order to know the pH, we're going to use an ice table. Here in this case, I'm going to put everything in molar concentrations, but I'm going to label the initial concentration of C0 just for sake of simplicity for when I fill the ice table. And we have an initial concentration of 0.17 molar. Okay. So the amount of water, it is not going to matter in our equation because that doesn't enter into any equilibrium equations. But I know that initially I'm going to consider that I have 0 of A minus and 0 of H2O plus. So now the amount of change, we're going to call it x, and x portion it is going to dissociate. Sometimes they call it alpha, depending on the class that you're taking. And we're going to produce plus x and plus x of H2 plus. So now at equilibrium, we're going to have C0 minus x, x, and x. And if you remember, the definition for Ka is the concentration of A minus times the concentration of H2 plus divided by the concentration of HA. And if we replace the values, this becomes x squared divided by C0 minus x. Okay, so now we're given that the Ka for this weak acid is 3.1 times 10 to the minus 6. That implies that the value for x is going to be small. So we can approximate that C0 minus x is going to be close to C0. So the value for x is going to be equal to the square root of C0 times Ka, which for us gives us the value of 7.26 times 10 to the minus 4. And what is this? This is nothing but the concentration of H2O plus that I have in solution. And now, how can I get pH? Well, pH is directly the minus logarithm of the concentration of H2O plus, which is going to give us a pH equal to 3.14. And that would be our final answer. Thank you very much.